Do we have questions over section 5.3 or 5.4 that you would like to go over now? Michelle, because your hand's so nicely raised.
Whenever we have to find the
Give me a problem from a section, I will do it.
I'll go with 17.
17 from which section?
5-4. Actually, she had a 15.
Negative 225. Now, how do I come up with, get out of there now. How do I come up with two angles that either add or subtract to give you negative 224? The first thing I want to do is I want to find the coterminal for this. Because I don't want to look at negative angles. I want to look at what? Positive angles. So I want to take 360, negative 225 plus 360, and what does that give me? 135. So if that gives me 135, my question to you is, what is 135? Is that on the unit circle?
Yeah.
Well, since it's already on the unit circle, do I need to do anything?
90 plus 45.
Since it's already on the unit circle, it is right.
How is that on?
Yeah, it's not on the circle.
Oh, yeah, it is.
90
Well, yeah,
plus
it is.
45.
90 plus 45. It's there. It's in quadrant 2, right? It's in quadrant 2. So I don't have to do the sum or the difference there because I can find them right away. And what is the sign in that quadrant? Positive square root of 2 over 2. What is the cosine? Negative square root of 2 over 2. And what is the tangent? Negative 1. I don't have to use those sum and difference formulas because it's already on the unit circle. Does that make sense? If it, I'm sorry? So if you want to actually plug it into the formula, then that means you're going to have the tangent of 90 plus 45. If you want to use that formula, that's going to be the tangent of 90 minus tangent of 45 all over 1 plus the tangent of 90 times the tangent of 45. Do we see that?
Why wouldn't you use negative 5 there?
Why wouldn't I use negative 225? Because I don't want to use a negative angle. You could. There's more than one way to get that. 135, its coterminal is negative 225. I don't want to do a negative angle if I don't have to. I want to do a positive angle. So that's why immediately I say find the coterminal to get the 135. Well, the 135 falls on the unit circle, so I'm not going to do any of this stuff. But as an example to show her, because she did it like this, it allows her to see where she's wrong. So if you're on page 368, you can see that that's the actual value that you'd be using. So what is the tangent at 90 degrees? Well, the tangent at 90 is going to be sine over cosine, so that's going to be 1 over 0, which is undefined. So minus, what is my tangent of 45? My tangent of 45 is negative 1. And this is going to be 1 plus an undefined. Can I do anything with this? Like, it doesn't even make sense to do the problem like this because you can't do it undefined. Do you see that? So alarm should be waving up in the air right away whenever you use the 90 like that. Okay?
Would you say it's sine over cosine?
Sine over cosine is good. Like, I would never do this. This is just so much more confusing and so much more work. Really, Donnie?
I was thinking, can you do an example of one of the ones from 1 through 6 on 5-4?
You're killing me. You realize that because I'm teaching stuff that's not on the test.
You said there was probably
1 through 6?
on.
No, it's not on the test.
Oh,
1 through 6 is not.
23 through something.
7 through 22 is on the test, and 23 through 30 is on the test. If I'm doing 23, Caitlin, are you listening to this?
Yeah.
This is off of the test. This looks like the test. So what trig function are you using? Off of the blue box on page 368. I know what U is. It's 60. I know what V is. It's 10. So which trig function out of that box am I using? Well, it's cosine, cosine. The only one's cosine, cosine deals with cosine. And am I adding or subtracting? I'm adding, so this is going to be the cosine of 60 plus 10, which is the cosine of 70. And I'm done. We have 6 problems like that on the test tomorrow. I can't get easier than that. True statement?
Oh, wait, never mind. I'm not.
You're not paying attention. Okay? We
So,
just
like,
do it.
if you have pi over 6 for those,
If I had pi over 3 and then I'd have to find the conversion of 10, then you just get a common denominator. You can type it in your calculator too. Fraction form 1/3 plus 5/7, right? That would be it. Okay. All right. Are there questions over 5-3? Because third period did an excellent job on review, and I wish I would have recorded their period today rather than yours. Nigel, are you tired or having a good nap today or what?
He must have been annoying you because he's mad at you.
like go over 1 through 6.
5.3, 1 through 6. What did you, on 1.3? 5.3?
Yeah, it doesn't matter.
Hey, I'll go get the statement.
Two sine squared. Okay, now what this wants you to do is simply plug and chug. So 2 times the sine of pi over 2 squared minus the sine of pi over 2 minus 1. Okay, so what is the sine of pi over 2? Sine at 90 degrees is 1. So I'm going to have 2 times 1 squared minus 1 minus 1. So this is going to be 2 minus 1 minus 1. So that's going to be 2 minus 2, which is 0. Does 0 equal 0? Does 0 equal 0? Yes, so that works. Part B was 7 pi over 6. So that's 2 times the sine squared of 7 pi over 6 minus the sine of 7 pi over 6 is equal to 0. So what is the sine of 7 pi over 6? You guys stop it and act your ages. I understand that right now you really think you're acting your ages, but please stop. You're annoying me and driving me insane. Okay? Now, what is the sine of 7 pi over 6? 7 pi over 6 is in quadrant 3, so it's negative immediately. It has a denominator of 3, so if we're looking at the hands of the clock, 1, 2, 3, that means my sine value would be, the denominator is 6, so the hands of the clock, cosine is 1/2, pi over 3, pi over 4 would be square root of 2. Cosine of pi over 6 would be square root of 3 over 2, so what's going to be my sine? 1/2. So I have 2 times 1/2 squared minus 1/2 minus 1.
This number's going to know if you should borrow 3 dry erase.
How about it? 1/2 squared is going to be 1/4. Okay, and I'm going to go ahead and get a common denominator here. This is going to give me 1/2 minus 1/2 minus 2 over 2. So 1 minus 1, that's gone, and it just gives you negative 1. I guess I didn't do it. Does negative 1 equal 0? No, so this is a no, it doesn't work. This is a no, it doesn't work.
You just probably to the A part. Maybe just want to.
on 5-3?
Yeah.
Yes.
Can you do 27?
Good idea.
Oh, I hate it whenever you guys don't notice. We even talked about the quadrant 3 as negative. I missed my sign, which makes that positive. We talked about it, and none of you guys caught it. So this gives me 1/2 plus 1/2 minus 1. That gives me 1 minus 1, which is 0. So yes, it worked. Sorry for the sign error. But I told you guys, and I just didn't practice. You guys are supposed to catch up. None of y'all caught it. Okay, 28. 27 or 28? 27 on 5-3. Didn't I do that one earlier today?
Yes, you do it right there, there.
Okay, 27. The directions on 5-3 say to do what? Find all the solutions of the equation of the interval 0 to 2 pi. So how do I go about doing this? I see how many different trig functions up there. I see 3. That's so not cool. So what I have to do is I have to make this to have sine and cosine values. So tangent is actually going to be the sine of x over the cosine. And then I'm going to put this over 1. Marry the tops and marry the bottoms there. So that gives me the cosine of x plus the sine squared of x over the cosine of x is equal to 2. I'm sorry.
Oh, Steve. Sorry, help us not check them
Only
out.
one button.
Number 5. No, you actually have to use the formula on page 360.
Like on paper, that's only.
Oh, wait a minute. Oh, yeah. They want you to use the formula on the screen.
We're like, no, you're not using it.
Okay, I need a common denominator here. So what's my common denominator between 1 and cosine? Cosine, so this is going to be the cosine of x over here, and the top is cosine squared of x, plus the sine squared of x over there, over the cosine of x. And now, since they have the same denominator, I can make it equal to 1 fraction. So cosine squared of x plus the sine squared of x all over the cosine of x is equal to 2. And what is cosine squared plus sine squared? 1. So what I now know is 1 over the cosine of x is equal to 2. That is secant, and I'm going to write that down. But if I know that secant is 2, then what do I automatically know? That cosine is 1/2. Our brain works in terms of sine and cosine, correct? Our brain does not generally work in terms of secant and cosecant, correct? Because that's not what's on a unit circle. So I want to find all the angles on the unit circle that have a cosine of 1/2. So if we're looking at all the angles on the unit circle with a cosine of 1/2, that means it's positive in quadrants 1 and 4. That's where my cosine is positive. Do we see that? So what angle has a cosine meaning an x-coordinate of being 1/2? Pi over 3, and then down here, 5 pi over 3. So x is equal to pi over 3 and 5 pi over 3. Those are all the angles on the unit circle that have a cosine of 1/2. Do we get that? Yay or nay? Yay? Are we good? Any other questions over those sections?
Why is it so much easier watching YouTube?
I have no idea.
You just play on.
Nice. Okay, so if I'm looking at 21 here, I need to immediately bring this all over to one side of the equation, correct? So I am going to make this 3 tangent cubed of x minus the tangent of x is equal to 0. So now what do you notice about each one of those terms? it has a tangent in it. So if I pull out a tangent of x, I'm left with 3 tangent squared of x minus 1 is equal to 0. So I pulled out my lovely little GCFs. Now I set each, the GCF and the parenthesis, equal to 0. My GCF is my tangent of x is equal to 0. And then I have 3 tan squared of x minus 1 is equal to 0.
What else does 3 turn into a 2?
Because I'm pulling out a tangent, and 3 tangent cubed of x divided by a tangent gives me 3 tangent squared of x. Do you understand that? Okay, so now over here I'm going to have 3 tangent squared of x is equal to 1, so the tan squared of x is equal to 1/3. Now how do I get rid of that squared concept? I'm going to square root both of those, so I have the tan of x is equal to plus or minus 1 square root of 3. Do I like that?
I enjoy it.
I don't, because it's not rationalized. So the tangent of x is going to be plus or minus the square root of 3 over 3. So I want to know what angles on the unit circle have a tangent of plus or minus the square root of 3. Get out your hand in the unit circle, and which angle has a tangent of the square root of 3 over 3? 30 degrees. So 30 degrees is going to be pi over 6. That's positive in quadrant 1. Well, is there another angle that's negative in quadrant 2? Well, in quadrant 2, it's 5 pi over 6. And in quadrant 3, it would be 7 pi over 6. And in quadrant 4, it would be 11 pi over 6. So those 4 answers represent the right-hand side of it. However, we never finished this one over here. So what has a tangent of 0? Well, if you're on our lovely little unit circle, we have the point 1, 0, we have the point negative 1, 0, 0, 1, and then 0, negative 1. Tangent is what? Sine over cosine. So that's my y value over my x value. So that's going to be 0 over 1, which is 0, 0 over negative 1, which is 0, 1 over 0, which is undefined, and then negative 1 over 0, which is also undefined. So what are my coordinates that have a tangent of 0? 0 and pi. Do we understand those 6 answers there, yay or nay? Are we good? Anything else? Okay, tomorrow's going to be the test. It will be a 1-period test. I'm going to shorten the test so that it's less for you. You can expect at least 1 radian and at least 1 degree. I will keep all 6 of the top ones because if you recognize the formula, okay? I may delete one of them.
Or several.
I don't know.
It'll probably be the easy one.
Well, keep one of the
I want this finished in a period. So I will shorten this bad boy until it will be finished in a period. Because you either know it or not.
Are you gonna take it just to check how fast?
How long it takes? Sure.
I know you.
She'll take it within like 3 minutes.
Oh, she'll take it and then multiply.
Whenever I take it, I multiply it by 3. It's supposed to take you 3 times as long as it takes you 3 times.
I hope it takes
Well,
all periods.
6 times.
Okay?
We'll have to do it for today.
Make my husband do it.